Good morning, dear students. I hope all of you are fine. Stay safe at home. In our previous classes, we have learned about polynomials, and especially in the previous class, I have completed how to use long division method in case of polynomial, or also you have used how to find the remainder by using remainder theorem. And some student has doubt in the last class. I tried to clear them through message or phone call. Today I am going to continue again exercise 2.3. There are two questions, question number 3 and 4, and after that I am going to start a new topic, that is factorization of polynomials. Okay, then let's start the class. Now we are going to solve question number 2 from exercise 2.3. You can see clearly that question number 2 is find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. Means you need to find the remainder when x cube minus ax square plus 6a minus a is divided by x minus a. So this is solution. Now see, first of all, this one you have to write as px. We have px is equal to x cube minus x square plus 6x minus a. Now using remainder theorem, when you write using remainder, actually I need to write this one in one sentence. Okay, so write this one in one sentence. I hope you understood using remainder theorem. Then if you find out the value of x, then x minus a is equal to 0, x equal to a, then replace x by a. That means you have to write pa, then in the place of x, what you have to write? A cube. Now what is there? Ax square. See, already a you have. Okay, so this a you have to write a. Then in the place of x square, you have to write again a square, because the value of x is you have to replace by a. So a into a square. Then 6 into x, I wrote 6 into a, then minus a. Then a cube, a into a square, again a cube, 6 into a, 6a minus a. Minus a cube plus a cube cancel out. And what is left? 6a minus a. And what is left? 5a. So therefore what? We know that after simplifying, what is the result? That will be the remainder. Therefore the remainder is equal to what? 5a. So like this you can find out the remainder theorem. Like this you can find out the remainder. Understood? First of all, we have to find the value of x. After that we have to replace x by the value of x. Means here the value of x is what? A. So replace x by a. Clear? Okay. Now today's topic is what? Factorization of polynomials. So all of you know what is factorization? So example, suppose you are having number 12. This is example. Okay, so what are the factors of 12? Do you know? 2 into 6, then 6 you can bracket 2 into 3, then 2, 2, 3. These are the factors of 12, because 12 is divisible by 2 and 3. Or in class 8 you got the factorization of polynomials also, like x square minus x. So what are the factors of x square minus x? You can get common, like x common, x minus 1. You know what is common? If you take x common, then what is left here? X, then x already common, what is left? Minus 1. So here the factors of x square minus x is what? X and x minus 1. This is a simple example. Now suppose you are having a polynomial px, 2x cube plus 2. So in factorization you can use remainder theorem, okay, and factor theorem. About factor theorem I will tell you after some time. See this example. Suppose px is equal to 2x cube plus 2. If you put x equal to minus 1, suppose you are putting in the place of x equal to minus, maybe you are thinking why you need to put x equal to minus 1, and this is just an example. Okay, you can put anything, but this is just an example that for what value of x you will get the result is 0. That is called 0 is the polynomial. All of you know? Yes. So suppose here x equal to, I am putting minus 1, then after putting minus 1 in the place of x, minus 1 cube plus 2, minus 1 cube means what? 3 times minus 1 multiply, then again you will get minus 1, 2 into minus 1 minus 2. then plus 2. Then finally minus 2 plus 2 cancel. What is left? 0. See, now according to the remainder theorem, what? 0 is the remainder. 0 is the remainder. So I'll give you clear. I'll explain clearly. See, here when you're putting x equal to minus 1, you're getting 0. Okay. Now see, the remainder is 0. The remainder is 0 means what? That means how we got the value of x? See, x plus 1. If you divide by x plus 1, if you divide 2x cube plus 2 by what? X plus 1, then if you use remainder theorem, means when you use remainder theorem, one need to find out value of x. Then what is the value of x? X plus 1. Then one need to do, this is x plus 1. X plus 1. Suppose you have to divide 2x cube plus 2 by x plus 1. Then when you use remainder theorem, that time you need to find out the value of x like this, x plus 1 equal to 0, then x equal to minus 1. Yes or no? That means when you divide 2x cube plus 2 by x plus 1, when we divide 2x cube plus 2 by x plus 1, if you use remainder theorem, we will get the remainder is what? Remainder is what? 0. Understood? So according to factor theorem, what is this? According to factor, try to understand. According to factor theorem, we can say that x plus 1 is a factor of px. In generally, when you divide a number or a polynomial by any polynomial or any number, then if the remainder is 0, in case if you get the remainder is 0, means you can say that it is divisible or not. Otherwise it is not divisible. We are getting the remainder is 0. That means it is clear. Suppose 6. If you divide 6 by 2, 2 3s are 6. Then remainder is what? You will get the remainder is of course 0. 3 is the question. In that case, you can say that 2 is the factor of, see, if you divide 6 by 2, 2 3s are 6, then what is left? 0. In this case, we can say that 2 is the factor of 6. Similarly, since x plus, when you divide 2x cube plus 2 by x plus 1, we get the remainder of what? 0. According to the remainder theorem, this is the remainder. So that means what? X plus 1 is a factor of px. That means x plus 1 is a factor of px. And this is only factor theorem. See, what is factor theorem? I have written the theory here. If px is a polynomial, like that, if px this is a polynomial, if px is a polynomial of degree greater than or equal, this is greater than or equal to 1, means degree is not equal to 0. Here it should be greater than or equal to 1, and a is any real number. So here see, suppose a is any real number, means here you see, when you are taking x plus 1, 1 is a real number or not? Any real number. Then x minus a, they are taking x minus a, we got what? X plus 1. Similar case, x minus a is a factor of px if pa is equal to 0. Try to understand. When they are taking x minus a, if you find the value of x like that, x minus a is equal to 0, then x equal to what? A. Yes or no? Then pa is equal to 0. Understood? Similarly, you see, if in the place of x plus a, x minus a, if you write x plus 1, then what? P minus 1 is equal to 0. You are getting or not? It is satisfied. This remainder factor theorem is satisfied this one or not? Yes. So if pa equal to 0 and two number condition, if pa equal to 0 if x minus a is a factor of px. That means like that. In this case, if p minus 1 is equal to 0, then x plus 1 is a factor. Or if x plus 1 is a factor, then p minus 1 is equal to 0. Try to understand. If you get p minus 1 is equal to 0, then we can say that x plus 1 is a factor. And suppose you are getting already, it is said in the question that x plus 1 is a factor of px. Then obviously, if you put the value of x, you will get what? 0. This one only, see. If x minus 1 is a factor, px, then p is equal to 0. Understood? Or pa equal to 0 if x minus 1 is a factor of px. All of you understood? This is called factor theorem. Clear? I hope all of you understood this one. Next. Now see, exercise 2.4. Determine which of the following polynomials has x plus 1 a factor. Means you have to find out this x plus 1 is a factor of this one, or there are two more questions. There are total 4 questions. I am going to solve 2 of them, 1 number and 4 number, and I will see either x plus 1 is a factor or not. So you can check for the others. Understood? Next, question number 1 number and 4 number. See. So first of all, using remainder theorem, or directly you can write what they have given, x plus 1. So here x plus 1, find the value of x, then x equal to what? Minus 1. Px is equal to, I am taking x, means already given px, x cube plus x square plus x plus 1. Understood? Now p minus 1. Ultimately you are using remainder theorem, okay? You write we have, or you can let let also. P minus 1, then in the place of x minus 1 cube, because you have to replace x by minus 1, since you have to write here since, then minus 1 square plus in the place of x minus 1. Don't forget this one plus already is here, then in the place of x again minus 1, then what is left? Again plus 1. This is plus. Now minus 1 cube means all of you know minus 1, and minus 1 square means minus 1 into minus 1 plus 1, and this plus minus 1 again plus 1. See, minus 1 plus 1 cancel, again minus 1 plus 1. What is the remainder? What is the remainder? 0. So now you can use the factor theorem. See, p minus 1 is equal to 0 means what? X plus 1 is a factor according to factor theorem. Understood? Now you can apply. They are using factor theorem. What you can write? X plus 1 is a factor of px. Understood? I hope all of you understood this one. Clear? If you want to write here using remainder theorem, you can write. Otherwise, you write you have also. Okay. Next, question number 4. So in number 1, what do we got? X plus 1 is a factor of px. Now, for number, so we have px is equal to what? X cube minus x square minus 2, this is bracket, okay, 2 plus root 2x plus root 2. Then already you know for x plus 1 you have to check, so p minus 1 minus 1 cube, already minus you already here, don't forget that this minus is there, no need to put minus 1, no, this minus is different, this minus already here, so you have to write again minus 1 square. Try to understand each of the term, don't try to remember, you have to get the clear concept, okay? Then into minus 1, because x is multiplied 2 plus root 2, then what is left? Plus root 2. Now minus 1 cube means minus 1 3 times multiply, then you will get minus 1, then minus, this minus already here, for minus 1 square, minus 1 into minus 1 plus 1, then 2 into minus 1 minus 2, root 2 into minus, because both of this you have to multiply with minus 1, minus root 2, and already we have plus root 2, minus root 2 plus root 2 cancel, then minus 1 c, minus 1 again minus 2, minus 1 minus 2, minus means minus 1 minus 2 again minus 2, so minus 4. All of you understood? See clearly? Okay, then we got the final result is what? Minus 4. As you are getting the final result is minus 4, that means what? The remainder is not 0. Means p minus 1 is not equal to 0. So therefore what? Therefore x minus 1 is not a factor of px. All of you understood? This calculation you see one step. Once again, 2 into minus 1 minus 2, root 2 into minus 1 minus root 2. And already you have plus root 2, that is a minus root 2 plus root 2 cancel. This one minus 1 square plus 1 plus 1, again minus is there, minus plus minus 1, minus 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 2, and this one again minus 2, so minus 4. So we are not getting 0, so x minus 1 is not a factor of px. Okay? Clear? See your homeworks. Exercise 2.3 question number 4. Exercise 2.4 question number 1, sub number 2 and 3, because 1 and 4 I have done. Question number exercise 2.3, question number 4, exercise 2.4, question number 1, sub number 2 and 3. Okay, please submit your homework in the evening. In case any doubt, please get back to me in the evening. Thank you so much. Have a nice day ahead.